All right, we're gonna go ahead and get started. We're gonna talk about graphing polynomial functions. We talked about end behavior and we talked about degrees and leading coefficients already. So you're just kind of building onto that. So this is gonna be factored polynomials. So eventually we're gonna learn to factor these higher order polynomials, but right now they're already factored for you. And what they want you to do is pull out the degree and the leading coefficient. So to find the degree of a factored polynomial f of x we add up the degrees of each of the factors of f of x. To find the leading coefficient of a factored polynomial, f of x, you're going to multiply together the leading coefficients of the factors f of x. Okay. So let me remind you what degree and leading coefficient are. What we had was a polynomial that looked like this, not factored, just written out. Remember, our degree is our highest power. So what is our highest power? 6. They won't always be in order, but most of the time they will. So we know we're looking at this term. So our leading coefficient was what? -3. What do those things tell you? What does the degree tell you? If it's even or odd, what does even tell you? They point in the same direction. So this one is even, it would be pointing in the same direction. If it were odd, what would happen? Opposite directions. Good. So then your leading coefficient tells you which direction it points. So this one is even, so it points in the same direction. But our leading coefficient is negative, so which way does it point? Down. If it were positive, it would point up. If it's opposite and it's negative, it's decreasing, so the left side will be pointing up, the right side will be pointing down, and then vice versa if it were positive. So that's what you've learned the last 2 days in this class. Is everybody good with that? So now what they're doing is they're just factoring it. So they're giving you a factored form, and you have to figure out what the degree is and the leading coefficient is from a factored form. It's very simple, just like it said. To find the degree, you're going to add up all the degrees. So we're going to start with this first. I'm going to split it up. I'm trying to do it with a different color so you guys can see. Into terms. And the 2 is a term. But since it doesn't have an x, it's degree. And I'm going to do the degrees on the top and the leading coefficient on the bottom. So you'll see it. The degree of 2 is 0 because it does not have an x, okay? So no x means a 0 degree. This is x to the 1. So you're looking for the highest power inside of the parentheses. This is x to the 1. What's the highest power in the next set? 1. And in the final set? 1. You just add these up. And you get that our degree is equal to 3. So if I multiplied this all out, my highest thing would be x cubed. Has everybody got it? So you just add all the x's. Okay. For leading coefficient, you're going to get all of the leading coefficients and you're going to multiply them together. This 2 in itself is a leading coefficient. Does everybody understand that? It's a leading coefficient. So I'm just going to bring it straight down. It's a 2. We're going to multiply these together. You said your highest power was 1 in this factor. What is the leading coefficient of that x? 1. What is the leading coefficient of the next x? 1. What is the leading coefficient of the final x? 1. So your leading coefficient is 2 times 1 times 1 times 1, which is 2. I'm going to go ahead and go a little further. What's this going to tell us? Do they point in the same direction? Opposite directions because it's odd. And this means it is increasing. Yeah, positive or increase. I don't care which one you say. So if I sketch the graph, it would look something like this. Okay. Again, it could be curved with stuff in the middle, but your left side would be going to negative infinity and your right side would be going to positive infinity. Everybody good? All right, so just reviewing what we did last week so we don't forget because it's easy stuff. Next one, g of x. We're going to start with our degree. I'm going to split it up again. Remember that this is a -1, so its own entity. It is its own entity. We have a square on the back of that, so we got to keep that there. We got a cubed on the back, and then we have the x plus 7. All right, so does this first term have an x? So its degree is 0. This one has an x, but what else does it have? A square. So when I multiply this out, what am I going to have as my highest power? 2. And remember, we're just adding those together. What's my next one's highest power going to be? And then the last one? 1. So what is our degree? 6. Is everybody okay? It's literally that simple. Don't make it too hard. Leading coefficient. What's my coefficient of this first term? Oh, -1. Good, good, good. The middle one right here, or the next one, the second one? The one with degree 3, what's your leading coefficient?
4.
Remember, it's the number within the x. Now, what's going to happen is these are all 1s, but technically what you should do is square them. So if you get a number other than 1, you want to put that power on it, but it's not going to change our 1 at this point, so you're not going to see it. Does everybody understand that? You're not going to see it. And then the last one is also going to be a 1, which gives us a leading coefficient of -1. What does this tell us? Same direction and down or decreasing. I don't care which way you say it, both are correct. So the sketch would look something close to this. Again, there might be some crazy stuff in the middle. So on the left side, it goes to negative infinity, and on the right side, it goes to negative infinity. All right. Let's look at C. I'm going to split it up again. We're going to do degrees on the top. What's your degree of -2? 0, because there is no x. X minus 3? 1. X plus 1 squared? 2, because it has a squared. 1 minus x? 1. There's only one x. Don't let it fool you because it's backwards. We're going to add it up and get our degree is 4. Perfect. Now, that 1 minus x being backwards will affect the leading coefficient, okay? So it will affect that. It will not affect the degree. What's your leading coefficient of the first term? -2. Second term? 1. The third term? 1. Don't forget to put the square on there so you can go ahead and start practicing that. And then of the last one? -1, because it's a minus x. Good job. So your leading coefficient is? +2. What does that tell you? Same direction, and that is positive. So it'd be like a U shape. Good job. Anything hard yet? Pretty simple, right? Just watch those squares if you get a different leading coefficient. So you'll see it in just a second. All right, split it up again. Degree of 3. X plus 1. 3 minus x cubed. 3, because it's a cube. 4x squared plus 1. 2, because it's x squared. Add it up, you get a degree of, good. The next is your leading coefficient. What's your leading coefficient of your first term? Second term? Third term? -1 to the third. Don't forget that cube. That's going to make a difference. And then? Do you do 4 to the second? Why not? Why is it different than the middle one or the next to last one? Yes, you only do the square or the cube if it's on the outside. This one's already put into it, so you already know that that's your leading coefficient. Right? This -1 cubed is still going to be -1. Okay, so 3 times 4 is 12, times 1 times -1 is 3 times 4 is 12, times -1 times 1 is -12. What's that tell you? Same, and decreasing. So it's going to look like this. Very good. Any questions on the first page? Zoomers, any question? You guys good? Y'all are awfully quiet today. This is why y'all have to answer on Zoom when y'all are at home. I love it. All right, look at your next one. All right, so I'm going to skip the top part for a minute. We'll get back to it. It says find the y-intercept and x-intercepts of the following polynomials. And that's all that those 3 bullets are telling you how to do it, okay? But I think if I show you, you'll learn better than if I just write it up there, okay? So to find the y-intercept, we're going to plug in 0 for x. That's the easy one, y'all. The y-intercept is always the easiest. So I'm going to do both of these with the y-intercept first, and then we'll go back and do the x-intercept, okay? Okay. So remember, f of x is the same thing as y. So I'm going to change it to y equals. And then we're going to do 2 times, and we're going to plug in 0 for x. 0 minus 3, 0 plus 1, and 0 plus 5. And then we're just going to multiply it together. So the y-intercept, that's why it's so easy, is because it has zeros. It's real easy. 2 times -3 times 1 times 5. 2 times -3 times 1 times 5. -30. So your y-intercept is at -30. If they ask you to write it as a coordinate, you plugged in 0 for x, and you got -30. Okay, so you can show me either one, it's fine, but if you get the quiz where it has like not multiple choice, if you get a quiz where it has the coordinates, you know how to write them. Okay, I plugged in 0 for x, and I got -30 for y. All right, so for the next one, same thing, we're going to do y equals -2, plug in 0 minus 3, plug in 0 plus 1 squared, 1 minus, plug in 0. We get -2 times -3 times 1 squared times 1. -2 times -3 times 1 squared. 6 times 1 is 6. So my y-intercept is 6. What would my coordinate be? 0, 6. That's it. Right, so your x-intercepts are also easy when it's in factored form. Super easy when it's in factored form. If we tried to do that the other day, we would have to factor it and then set each factor. So it takes a lot longer if it's not in factored form. This is not bad. So your x-intercept, you're going to plug in 0 for y. And you will have multiple x-intercepts, okay? Multiple x-intercepts. So remember, it's y equals, so this time we're going to plug it in. 0 equals 2 times x minus 3, x plus 1, x plus 5. We did this when we factored polynomials a couple weeks ago, or a week ago, or whenever we did it, okay? Is everybody good? So once we get it factored, we set each factor equal to 0. I'm going to work it out this time. The next one, you can do it the cheater method way. That's fine. I want to show you this first one. Your first factor is 2. When I set it equal to 0, it does nothing. So when I tell you, when we start factoring higher ordered polynomials, that a GCF doesn't matter in the solution, it doesn't. It matters in a factor. It does not matter in a solution because it cancels itself out, okay? X minus 3, set that equal to 0. We add 3, and we get 3. So that's your first real x-intercept. We would do x plus 1 equals 0 and subtract our 1 and get negative 1. And we set x plus 5 equal to 0. Subtract 5 and we get x equals negative 5. But remember, we can do the cheater method. If we have a negative 3, we know the answer is positive 3. If we have a positive 1, the answer is negative 1. If we have a positive 5, the answer is negative 5. What are my coordinates, though? What's your coordinate if x is 3? Yeah, I had 3 and I plugged in 0 for y. I got negative 1 for x because I plugged in 0 for y. I got negative 5 for x because I plugged in 0 for y. They are probably going to want the coordinates more than they will the x equals. I'll accept either one. But again, if it's multiple choice, I think that they use the coordinates instead of just doing x equals blah, blah, blah. Okay, so be ready for that. All right, so for the next one, we have 0 equals, this is your x-intercept. 0 equals negative 2, x minus 3, x plus 1 squared, and 1 minus x. All right, so the only weird one is this x plus 1 squared. And what does square mean? What does it mean to square? You multiply it by itself, so it's the same factor. So when you see this, that just means there's 2 factors of x plus 1. All right, so again, when we set these equal to 0, this x equals negative 2, it doesn't matter. This x minus 3 will give you positive 3. Is everybody okay with that? What this will do is give you negative 1 2 times. That's all that means, negative 1 2 times. This is why it's important when we get to the higher order factoring, whatever your degree is, so say it's the 6th degree, you should have 6 solutions. Does everybody understand that? We had cubes, we had 3 solutions, we had 1 real and 2 imaginary. It goes the same way. If you have 6, you should have 6 solutions. Your 6 solutions, one of them could be repeated like this one, okay? So this counts as 2, and we're going to talk about how we say it in just a second. So there's 2 more. And then your 1 minus x. Guys, don't get confused on this. Don't get confused on this. If I set it equal to 0, I don't like that negative x, so I'm going to add x to the other side. And I get 1 equals x. Don't get confused and put negative 1, okay? Just be careful. You did it, didn't you? Just be careful. Everybody does it. It's okay. I get it every year. All right, so we're going to talk about this double root right here. I call it a double root. They call it using multiplicity. The multiplicity of an x-intercept is the number of times that particular x-intercept occurs. So this one, because we've already done it, you would say x equals negative 1 with a multiplicity of 2. That means it happens twice. So if it were cubed, it would be a multiplicity of 3. Make sense? Pretty simple. It's not too bad, guys. All right, so state the x-intercepts with their multiplicities of the following polynomials. So remember, the negative 1 in front doesn't matter. What would this answer be? What would this answer be, this x-intercept? X equals 2. With a multiplicity, and you can just write it like that. That is fine. I don't need you to write out multiplicity 500 times because it's a big, long word. I just don't need to see it, okay? How many times is it going to occur? 2, because it has a power of 2. That's all you do. What about the next one? What is your x-intercept? -1 with a multiplicity of, and then this last one, x plus 7, changes into, it does not have multiplicity. If you see it say that, it'll be multiplicity of 1, but they don't do that because it's not a double one. Okay, so you don't have to put it on that. All right, so again, we look at this one. Your -2 doesn't matter. Remember, it's just a GCF. It does not matter in the solutions at all. Your first one, what is your x-intercept? Does it have multiplicity? No, it does not have multiplicity. It only happens once. What about this next one? -1, how many times? Multiplicity of 2. Be smart about this one. 1 minus x. And no multiplicity because no power. That's it. Any questions? All right, I'm going to skip this next page. And I'm going to skip the steps for a minute. I'll tell you what I like to do first, okay? It already tells you to sketch the graphs of the following polynomial functions and label all the x and y intercepts. So that's what I would do first, is the x and y intercepts, okay? That gives you some good points. So let's look at number 1. I'm going to graph it on the first graph, and number 2 will be on this one. All right. So the first thing that I want to do on number 1 is I'm going to do the degree of the leading coefficient. And you can do it in any order that you technically want to. I typically do this first so that I know what it looks like before I even start. Okay. So look at number 1. What's your degree? What's the degree on the top? What's the degree of -1? What's the degree of x plus 2? 1. What's the degree of x minus 1? What's the degree of x plus 3? We add those together. And our final degree is, what does that tell you? Opposite directions. Okay. Do the same thing with your leading coefficient, but you got to multiply them together. What's your leading coefficient of the -1? Yeah, -1. Leading coefficient of x plus 2. Leading coefficient of x minus 1. Leading coefficient of x plus 3. So what is your total leading coefficient? Which means it is decreasing. So it's going to look like this. So our end behavior should look as positive infinity on the left and negative infinity on the right. All right. So then I'm going to move down a little bit. I'm going to rewrite this so we can see it. You guys don't have to rewrite it. And I'm going to find my x and y intercepts. This is the function. I just need space. You guys can keep writing where you're at. Okay. So your y-intercept, how do we find our y-intercept? Make the x 0. So -0 plus 2, 0 minus 1, 0 plus 3. So we have -1 times 2 times -1 times 3. What is our y-intercept? What is our y-intercept? 6. What's that coordinate?
0, 6.
Okay, so I'm going to plot that. And again, it's just a sketch, so we're not trying to kill ourselves to plot this, okay? Then we want to find our x-intercepts. Bless you. Bless you. So our x-intercepts come from our function again. What is this x-intercept? -2, and as a coordinate is -2, 0. What's your next one? 1, 0. And your last one? -3, 0. I'm going to plot all those. -2, 0, 1, 0, and -3, 0. All right. So everybody understands where all those coordinates come from, right? All right. So then to finish this sketch, everybody understand it's a sketch, right? So the things that I'm looking for are your y-intercept, your x-intercept, and your end behavior. Okay, everything in between is just going to be an estimate. All right. So what we said is because our degree was 3 and our leading coefficient was -1, it should start this way. Does everybody agree with that? It should end this way. Since nothing has a multiplicity greater than 1, it's all pass-throughs. And we'll talk about multiplicity in just a minute with the next one, okay? So anything with multiplicity of 1 or just repeats, does not repeat itself, you just pass through it. So we're just passing through. So we're going to pass through the first one. We got to go all the way through it. At some point, we have to curve back up to the next one. This little U shape in between these 2 points are where you're going to estimate. This may very well go all the way down to the end of the graph and come back up. You understand what I'm saying? Or it could just do a little tiny loop. We don't know. We're sketching. It doesn't matter. If we want to find out for real, graph it on your calculator. Okay, so all we're looking at here is being able to graph end behavior, x and y intercepts, and understanding what multiplicity does. We don't have multiplicity on this one, so all we're doing is passing through everything. So we're going to pass through. Somehow we have to go through the y-intercept. Again, it could go all the way up and come back down and then go through the y-intercept. It could top off at the y-intercept. We don't know, just as long as we go through it. So I'm going to go up and go through it. We got to get back down to this point, and since this is our last point, I'm sketching this graph really ugly, but I wanted you to get the understanding of this right here. This is what it's going to look like. Now, if you want to be super technical, and I suggest that you don't, okay, but if you want to be, you can take this back in. You do not have to do this. You can just watch me and put it in your graph. We're almost done. We're going to knock this out. Zoom 6. And this is what it's going to look like. And we're going to be pretty close. You guys see? We're pretty close, right? Mine kind of went sketchy because I drew that arrow at first. I would have kept it going straight down, but y'all got the idea, right? So we did pretty good. If you want to make it almost perfect, look at this graph and graph it, unless you just want to sketch it. Like I said, we could have made this go down like this as long as it came back up and touched it. Does it make sense? I'm not looking for this part on the sketch. What I'm looking for are these points and this end behavior. That's what I'm looking for, okay? All right, so we go to the next one. We have f of x is equal to x squared, x minus 1 squared, and x plus 4. We want to find our degree. What's your degree of your first term? 2. Your second term? 2, because it has a square. And your last term?
1.
We add those together. What's our total degrees?
5.
Perfect. Is everybody okay with that? We do our leading coefficient. What's our leading coefficient of our first term? But we got to do what to it? Square it. Make sure you put that square on there. That's where you guys will mess up on your quiz or your homework. So be careful about that, okay? X minus 1 squared. What's your leading coefficient? 1 squared. And again, we use the square because it's on the outside. If it's on the inside, don't worry about it. Then we have x plus 4. So our leading coefficient is, our total leading coefficient is 1. What do these numbers tell us? 5 tells us opposite. 1 tells us increasing. So it's going to look like this. Okay. The next thing that we're going to do is our x and y intercepts. Okay, x and y intercepts. I'm going to start with my y-intercept. It's the easiest. That's why I start with it. Plug in 0 for x. So 0 squared, I'm trying to get it all on the screen at one time. 0 minus 1 squared and 0 plus 4. 0 squared is 0. 0 minus 1 is negative 1. Squared is positive 1. And 0 plus 4 is 4, which gives us a y-intercept of, look at it. Look at it. 0. We're multiplying. Be careful. That's okay. Honest mistakes. So my coordinate for my y-intercept is, I plugged in 0 and I got 0. So I'm going to plot. X-intercept. I'm going to rewrite it real fast. We had x squared, x minus 1 squared, and x plus 4. Okay. What is this x-intercept? Means we have x twice, right? So we set both factors equal to 0. It's pretty simple, right? So anytime you see an x or a variable outside by itself, what is your answer for your x-intercept? 0 every time. Okay, so this is x equals 0 with a multiplicity of 2. That's important to know, okay? That's important to know. What about this one? X equals what? With a multiplicity of? And then the last one. Negative 4. Is everybody okay? So here's the difference. Multiplicities cause bounces. Bounces. What that means is your max or your min happens on that point. It's where it increases and then decreases, or decreases, increases. So we're going to talk about that in a minute. So this is a bounce, and I'll move it up so you can see it. And this is a bounce. But this one is not. It'll pass through it because it doesn't have a multiplicity. Okay, pass through. So I'm going to graph those. We have it at x equals 0, which we already have a dot there because it's our y-intercept as well. We have x equals 1, and that's going to be a bounce, and x equals negative 4, which will also be, no, it'll be a pass-through, sorry. So 0, 0 is a bounce, and 1, 0 is a bounce. Okay. Is everybody good with all this down here? I can move it up so we can talk about it some more. All right, so remember our graph should look like this. It should start low, and these two places are a bounce. Okay, so here's what we're going to do. We start low, but we got to end high. Okay, start low, end high. I have to get back to this point, so I'm going to have to make a maximum, right? Is everybody good? So I got to make a hump somewhere and go through it. But since this is a bounce, we got to come through it like this. It's a bounce. It doesn't go through it. It turns it. I got to get back to this point. So what do I have to do? Yeah, you just curve it back around. Another little loop. Can I go through it? No, because I have to end up here. So it's another bounce and finishes this way. So bounces are kind of weird. It's okay. But what can I do to make sure that I graphed it right? Check it in your calculator. Okay, so we're going to check it in our calculator real fast, and then we'll be done. And you can put it in the factored form. It's fine. X squared, x minus 1 squared, x plus 4. And like I said, this may be too high. This may not be high enough. I don't know. Zoom 6. So it started down. Look how high it went. It went way up here, and then it did a little loop, and then back up. Does everybody see it? So let me show you a little bit more. And you'll be able to see how it bounces at 0, 0, and then barely touches and bounces again. Does everybody see it? So again, if you're confused about whether it should bounce or not, just check your check your graph on your calculator, and that's perfectly fine. So any questions on this right now? Is everybody good? All right. Zoomers, if you don't have any questions, you are good to go. I'm going to stop sharing, stop recording.